I seem to remember I think the main takeaway, also what I just tried to explain to Marc-Antoine, and there might have been some insights, is I'm trying to define canonicality, and I still think we speak too loosely about what canonicality is, and I think deduplication, or the most centralized non-duplicated form, seems to be equivalated with canonicality, and I don't agree with that. For me, canonicality has everything to do with centralizing disagreements from a user experience perspective. And my main points that I tried to explain to Timothy was, I think the best way to do that is actually by having less formalization, because the more formalization you add, the more disagreement you can have on those formalizations, and you spread the disagreements. Whereas if you break it up and just put everything in a bin that's relevant, I believe you might get more canonicality in terms of centralizing disagreements.
Yeah, my belief is, my opinion on that is you get exactly the kind of disagreements we're trying to eliminate in the first place, which is disagreements based on definitions or interpretations. And, that has a place in the whole world. That's fine. We do it. I would say most of our debate is focused around different interpretations of the same statements. And that to me is a barrier to actually getting down to resolving something specific. But
I see the point you're making, Stephen, personally, but I would certainly not call that canonicality. I'd look for another name. It's another goal, and it's a worthy goal, but it's for many forces. I certainly stick with the original canonicality definition in the sense, because I think it's a very computer science classical meaning, right? There's one way to represent this and other ways resolve to the canonical way, and we can deduplicate through canonicalization. But the goal of saying, let's have the disagreement on the atoms separated from the disagreement on how the atoms are combined, because the disagreement on the atoms, if we can, a lot of things happens at the atomic level. And in a way, that's not contradicting what I think you're saying, Tim. Like the definition things you spoke about, their disagreement at the atomic level. And let's separate that disagreement from the disagreement on how are those atoms combined.
Well, yeah. I mean, part of my view on canonicality is it's not the statement or the words that make it unique or canonical, right? Mm-hmm. It's the concept. And okay, we've agreed that there's a place for more vague versions of claims, right? And we know that there's a scale in terms of ambiguity, right? So that we're always going to accept this ambiguity. To me, it's about defining exactly what set of definitions you're working with. And so canonicality is if you have two claims that seem to be about the same concept and are working with the exact same set of definitions, right? In the same set of predicates, those are canonical, right? You can say that, okay, the statement that has absolutely no disambiguation whatsoever is also a canonical claim, and you can have arguments there. That's fine. I just don't want to see that repeated. I don't ever want to see an argument.
How is this related to compound claims? Because you lost me there.
How is it? Well, it's related to canonicality. If compound claims are related to canonicality, we need to be right on.
But what's the relation between compound claims and definitions? Because I mean, I don't see how you just said.
A compound claim, to me, a compound claim doesn't have a definition, right? But I don't see how compound claims affect canonicality whatsoever, because to me a compound claim is not a claim.
Okay,
I would rather call them compound premise.
Yeah, but I agree with Marc-Antoine. Let's look for a different word than for what I'm seeking. Because I mean, it's easy to redefine canonicality and say I don't see how it affects that if you're interested in the definitions part, but I'm also interested in that. So, but then let's find a different word for what I mean, like centralizing disagreements. And what I'm saying is compound claims might complicate centralizing disagreement.
Yeah.
But I don't see how. That's the question. How does that complicate that? Because in my view of compound premises, there are no arguments applied to the compound premise. All arguments are made at they're either made at the atomic claims, or they're made on the support that uses the compound premise as a premise. So there's one place to put each kind of argument, right?
But this is where there would be another level. Like we could, I'm tempted to call it factorization, Stephen, by the way. It's about factoring a multi-premise argument into the atomic premises. Certainly, there can be disagreement about precisely for example, are A and B, like we have two support, A, B, C, to conclusion Z, right? So is A alone, B alone, C alone sufficient condition? Do you need A and B together? These are, you can disagree on, oh, is A alone or versus A and B need to be together for Z to be proven? So that's a disagreement about composition. And you're right, Tim, that it's on the, you said there's two levels, atomic and the other level, and it's on this other level. So I don't think we disagree there. But what Stephen is saying is this is a separate level of disagreement than the disagreement on the atoms. And if you put the compound claims, which I know, Tim, is not what you're saying, because you're saying the compounds are not claims, and I'm fine with that. I'm calling them claims for other reasons, but I agree, I think the compound claim is just for me an intermediate state until you factor it out into atoms. Progressive formalization, somebody wrote a compound claim by mistake. We factor it out as soon as possible, but and then we say, oh, this is equivalent to, and we only use the atoms as soon as we can. But there's still the notion that at some point—
a compound claim, wait, just to be clear, a compound claim under your definition is just a claim. You're calling it compound because conceptually there's two things going on in there, but it's still just a claim. There's no change in structure.
Exactly. And that's why I'm saying a compound claim is a claim in my view, but I agree with what you're saying. It's not a claim, and that we don't want to use it as much as possible. We'd rather have a multi-premise support. And then we can argue, is this support more appropriate than that support? And that's the other level of argument that Stephen's talking about. And what Stephen is saying is we need to separate those two layers, because if we have them together, it makes a mess, which I agree with. He's trying to avoid the second layer of argument altogether, which I don't agree yet.
I always said I'm not against formalization. I just want definitely the factorized view, whatever. I think the factorized view is a very important view to have, because any additional formalization, there might be additional disagreement about. And I even created a mock-up on Hangouts where I posted, like, I'm sure you can add your additional formalizations, but they're simply stuff that points to the base layers.
Yeah.
So yeah, no, I'm not against formalization at all.
No, the disagreement is this a good layer boundary? And
yes, exactly.
We started this conversation in the chat, which
and we have proposed moving forward with this approach by essentially proposing, when you want to propose a more advanced structure, a mapping from the advanced structure to the base layer, and see if that mapping makes sense, where information is lost, if it's possible to be a two-way mapping, all those things.
Totally agree.
And that segues into kind of what I wanted to do in this meeting, which is I tried to kind of do that with one of the structures that we all agree is important, which is the mutually exclusive concept. Now, before I go down that road, I know that Tal is here again, and he was brought in for a very different focus or a very specific question. So I'm wondering, Tal, if you would like us to go back to focus on what we were looking at with you, or if if you'll be here more times and we can go over that.
For today, I will only basically listen. I have to prepare what I've told you that I'll do. So I'm not prepared yet. So I hope Friday I'll be able to show something. So
Okay.
today,
We also have a meeting tomorrow. We're doing 3 days a week. Tomorrow,
yeah,
Felix
on Wednesday
runs the
I
show.
can,
But,
because
yeah.
I'm teaching, so I can do Tuesday,
Okay.
Fridays.
Okay. All right, then let me show you the diagram I sent. I didn't try to do anything formal. It's more a communication tool, and we could talk about how to formalize this kind of approach. Now I gotta find the diagram. Well, I'll just do my whole desktop here. Oh, there it is. Everybody see it?
Yep.
I don't know if I need to enlarge anything.
Oh, it's good.
Okay. So I picked, rather than, what's been controversial or much more complex topics that involve, scientific studies to prove and that sort of thing, I went for something much more simple and not even numeric in nature. You could say it's parameterizable. That's something that we don't have to talk about here. The parameter here, well, I started off with something that's not a claim and isn't necessarily part of the CD. It's not a structure we've been talking about, but I threw it out there as a starting point, which is the open question: where should we have dinner, right? And we know that an open question like that produces exactly the kind of mutual exclusion. And I'll also caveat this by saying that in real life, it's not so clean cut usually. In some cases it is. In other places, it's not mutually exclusive. Policy proposals, you could break up in little pieces, and then each piece could overlap with others, or you could choose more than one, for example. So this is specifically looking at a clean case of we have to choose exactly one. So they're all 100% mutually exclusive in their relationship. Okay. So here's the example. Propose 3 different places to eat: a pizza place, a burger place, a sushi place. And I put some example arguments that people might make based on price, based on taste, based on health. So this is kind of the starting thing of trying to make a decision like this, of people making arguments. Anybody have questions on this first view here?
I just comment that we have something that simulates this in the lib. So that's this case with pro and cons and everything.
Yeah,
and it's pretty common. Yeah.
It's IBIS, right? It was invented in the 50s, and there's been countless realizations of this.
Mm-hmm.
So the next realization is, and you see this in practice, this isn't just theoretical, is people start to realize that an argument that supports one of the options is also an argument against the other option. So if you're talking about price, then the fact that one is cheaper supports the cheapest option, but it also kind of opposes, you're saying at the same time, no, I don't want to go to these others because they're too expensive, right? So
for the opposite, it's not in general true. Like, burgers are bad for your health, do not support you should have sushi or pizza.
That specific statement, I disagree with that. A lot of my intuition also comes from when I have thought about implementing scoring here. But let's just say that you're going to have to choose between one of these 3. And the fact that you are opposing one automatically simultaneously increases your chance of choosing any of the others. Right? So a support or an opposition of one specifically simultaneously does the opposite action on the remaining.
If all the options are written down. If not,
that's the thing. It's a kind of default, but then you can check and say, oh, burger bad for the health also applies to the pizza. Pizza is bad for your health too. So really what's happening here is you have 3 criteria like, and you need to refactor the arguments into criteria applications. So there's the health, the cost, and the taste. And then you rank each option on those three criteria,
Right.
which is a totally
Okay, but we're
different
also
structure.
This structure here, other than the root node here, is a base layer concept, which means it's an argument map concept. And there's no way in a standard argument map to do those things you have said, right? And so people who are trying to support their preference will naturally start filling in all these connections, right? Which is to say, well, you know, somebody says, no, we should have dinner at Sushi Joe's. You go, no, pizza's more affordable. You might create a separate one that says sushi is expensive, right? Which I actually did as an opposition over there. But you're actually making both arguments at the same time. Hey, pizza's more affordable, right? Which means you're arguing in favor of pizza. You make another one that sushi is very expensive. Well, anytime you do these things, let's say that it's the health question and you want to argue pizza isn't healthy. Burgers aren't healthy, right? If you look at it in terms of scoring, again, it's the same thing of what I consider to be an opposite and equal reaction, which is if you have three options here and you say, well, okay, pizza is unhealthy. You pulled pizza down, that kind of floats the other two up. And when you say burgers are unhealthy, you've essentially pulled burgers down to the level of pizza, assuming they have equal weight, and you've pushed sushi up even more. So you actually do make each argument separately. The effect comes in this balancing in terms of scoring of what you're going to choose. So you would, you know, even though they're overlapping in the sense of they're all about health, you make each argument individually, and they have an, you know, in the case saying burgers are unhealthy supports pizza because you've already argued pizza's unhealthy, and so it kind of pulls it back up. Essentially, is what I'm saying. Does that make intuitive sense to you?
It makes sense, but it overlooks something quite critical, or maybe not. Maybe that's where you headed. But I mean, I modeled like a false dichotomy. Like, well, in this case, it's a false trichotomy like this in Socrates, like underscores versus camel case. And there's a reason why on Socrates I don't allow statements like more expensive. I don't allow that because it's indexical. It necessarily relies on the comparison for that claim to be able to be evaluated. So the only way is either you mention more than what as part of the claim, so it's no longer indexical, or you break it up in separate evaluations that indeed, like Marc-Antoine highlighted, then you can compare across a range, and you can also include options that are not part of the currently listed options.
Would pizza is cheap also be indexical?
No, but I mean, the point is if
it's pizza is cheaper than what?
Yeah.
Pizza is cheap is a fact. Pizza is cheaper.
Yeah,
pizza is cheaper than sushi.
The mutual exclusion only works if you pull in the context that it is a false dichotomy. And I even wrote in the paper at the end of the result, like the downside on Socrates is in each and every claim you need to add that you're arguing about a comparison, but it's also the upside because you're emphasizing that all of your arguments are actually false dichotomies. And the way to go remove that is not by modeling them, but is moving towards something like Marc-Antoine was suggesting, where you say price, and then you just say it's very expensive, it's cheap, and then you can start comparing any option against each other.
Yeah.
And then if you indeed add like you're doing now, then it works. Then they are mutually exclusive.
The beauty of I agree that either rank or go binary with explicit reference, because the problem is when you say pizza is what is it? Sushi is expensive or is more expensive, then you add another option that is even more expensive than sushi and it becomes false, right? I want, I don't know.
It has to do with like how decontextualized you want to be as well.
And this is why I insist so much on doing everything with event sourcing, so that you know that the event, when the statement was made, this was the utterance context, and the other context came later. The other statement came later.
Yeah, or all these claims are in the context of should we have dinner at sushi, burger, or pizza? I mean, you can do it like that.
You can do it like that.
Couldn't it be, for instance, that sushi cost $10, pizza costs $5, and I can then say that for me the difference between $10 and $5 is nothing. Okay, so why can't I give it values and then later on evaluate health?
Valid.
Yeah.
So, I mean, all these things are possible. The question is, you know, are we going to force people to structure their arguments in that way? That wasn't the goal.
And that's the whole progressive
that wasn't the concept of
argument.
Right. So, like, I think
People will
there's
write.
a very good point there that when you're comparing two things, it's good to break it up like that. But sometimes people just make generic statements like, you know, burgers are the best food in the world. And that's going to be their argument for going to the burger place. They're implicitly saying burgers are better than sushi. Burgers are better than pizza. Burgers are better than Thai food. Burgers, yeah. But if they're required to do all that, it makes it even more intractable, the problem of fleshing out the argument map.
Yeah, people would starve then.
Buridan's ass.
And this is a problem when you're choosing where to eat with friends. It takes a long time already.
No, you ain't seen nothing. It's not the taste arguments. It's when, okay, I'm vegan, I'm gluten-free, all these constraints.
Those are harder constraints, though. There.
By the way, I think we can solve it, and partially I have some theory that can solve that, but it has several levels. For instance, in the lib, we have the intuitive decision making, which is I like, don't like, and this aggregates everything, and this is the first level. And then we have a further level for saying, okay, just a gut feeling evaluation of this is bad, this is good, and it evaluates according to bad and good. And if you want to go deeper, then you'll go put in prices, put in the health risk, etc., etc. So we are doing levels. And we give the group the ability to choose which level they want. If it's just friends, let's just vote up and down and go. Okay, 5 minutes and we are done. But if we're, if for instance, this is something we do in the lib, we want to help a community, and the community want to solve some problem, and you have to have price for that. Okay, so they are going into deeper level. So this is how we solve this issue.
But we're working here on a generic solution or a structure just to improve this specific problem.
I'm talking about a generic solution, but I don't know how to convey to you or to show it. But
I think what you just said, Tal, is what we refer to progressive formalization. That you start with one thing and then you decide how deep you want to go, how detailed you want to go, and so on. Yeah.
Right. But this exercise here actually is not so much to find the best model for this problem. What I'm doing here in this meeting is showing an example of proposing a better model.
Mm-hmm. Okay.
And defining how, describing the mapping to the base layer from this base layer to, or possibly back and forth, possibly not. That's one of the questions you have to come up with is.
And it's I mean, your general problem you're attacking is mutual exclusiveness, right?
Right.
In this case, okay.
Right. In here, I tried to show some of the mapping to what it would look like in the base layer, just because there's this, what the next picture is actually just showing is that one thing that's missing from here is actually, as we've talked about before, when you have this mutual exclusion structure, somebody inevitably says, responds or argues against one of the points by saying, no, we should do the other thing, right? So each mutually exclusive claim becomes an argument against the other claims, right? This is actually incomplete. There's a connection across here too. And that actually helps centralize or clean up the debate somewhat, because if you start arguing for or against a specific item, it automatically becomes an argument for or against the others, which is something I could possibly work out here. That's interesting. So this is actually a way in the base layer to clean this up. In here, we have something different. And that is something that I hadn't considered. So I'm thinking on the fly here.
Comparative things maybe we should drop for now. It's a whole different topic, I think. And then you need feature matrices, basically.
Depends on how you model it. I think in this case, he just wants to say this argument is for this choice and against the other choice. And
yeah, but it's not against, it's only against one of the other ones. That's the problem. It doesn't fit the other description.
Yes.
Suppose there's no pizza is more affordable than sushi. You just have pizza is more affordable than, sorry, let's remove the burgers one. That doesn't matter. Then, according to the mutual exclusion, this would also apply to burgers, because, how do you then make the argument only between those two? Because that's a use case. If you have automatic pro for something goes against the other ones, it's not absolutely a given. Like I can have 3 mutually exclusive and say A is better than B and mean nothing about C. Maybe C is at the A level, at the B level, or neither, above, below, doesn't matter. These are all possible. I'm just saying A is better than B. And that supports A, but it says nothing about C. And if we make it all implicit transitive, there is a risk of implying something about C that we don't mean. Suppose pizza and burgers are the same price. I know that's a counterfactual, but so I say, pizza is cheaper than sushi. I'm saying nothing about burgers, and I shouldn't.
I would just consider it as an example, indeed, that the mutual exclusion thing you cannot assume holds fully. Indeed, you need to choose on a claim basis whether or not it's mutually exclusive, which is another curation nightmare, but there's benefits to it, but I mean, it is yet another thing that people need to curate.
Yep. And this is why I'm so criteria, rank by criteria rather than keeping this as an argument tree. When at the beginning, Tim, you said this is hard to express in an argument tree. This is why I think argument trees are very limited. This is a perfect example of that.
But Tim, your way of thinking, I just want to see if I understand it correctly, is that you wanted to encode the mutual exclusiveness with not support, but contradiction. Oppose, sorry.
I'm saying this is probably the cleanest way to do it in the base layer.
But that was your goal, right? You wanted to encode mutual exclusiveness with opposition.
Well, so the goal or the proposal is to introduce a new layer 2 feature, which is a mutually exclusive set of claims, right? And I didn't try to detail it at all. I just wanted to throw this as an example of a proposal talk through it, show how we would propose a mapping from one to another, right? I see that there are more problems here than the simplistic example, which would have to be thought through in much more detail for the advanced structure. We'd have to think through all these different things that can happen and how they work. For example, this right here, this case of an argument that only refers to 2 of the claims, hasn't been considered here. So I would have to take this case and see how it will work in the mappings. But anyway, like from the simplistic level, I would propose just having some sort of set. I couldn't find how to do a dotted box on here. So it would be some sort of thing that would be a, maybe I could come up with a different kind of structure to show it. That would be,
make it without a fill.
Done. I've done it. It will take time to appear, I guess, but it's there.
Oh, you already did it? Yeah.
Yep.
Shut up. Okay.
If you'll refresh, maybe you'll see it.
In the past, it took
There
a few
goes.
seconds.
It happened. It appeared. Yeah, there it goes.
I agree totally with having a mutually exclusive claim set. I think that's absolutely necessary. It's a basic construct in OWL for a reason. But yeah, I'm just saying, let's be a bit weary of how we apply pairwise criteria, pairwise arguments to the mutually exclusive set.
I'm wondering what makes it mutually exclusive. So it's apparently the claim itself, not the relation between the different claims that are mutually exclusive, right?
Good question. Is it bound to the question or to the options?
No. It's bound to a mutually exclusive claim set would just be a set of claims that you are saying are mutually exclusive. And what that does is, what that does on an abstract thinking level is that it means you are stating that it is impossible for you to accept one of these claims without rejecting the others. That's what that relationship means.
But I think Stephen has a point. It is kind of a property of the question. Like there's many things, like let's look about what should we do about climate change. There's many kinds of actions, many of which can be taken. They're not mutually exclusive, and that's inherent to the question.
Not mutually exclusive.
They're not mutually exclusive, and that's inherent in the question. Where should we have dinner? And I assume there's an implicit all here, because if we were willing to split, then we could have dinner at more than one place. But that's a different question. So it's the structure of the question that makes it mutually exclusive.
Yeah, and for me, I mean, I struggled, like I said ages ago as well with this, and I have like some very early mock-ups where I just break down the question into features, and then each of the mutually exclusive sets as features, and then you have a claim for each of those features, and then you can just show feature matrix. So you avoid like, because a comparison with another thing in the set is not a feature that wouldn't be allowed basically. So in this case, you would say, where should we have dinner? Feature cheap, pizza is cheap, burgers are cheap, sushi, Joe's is cheap. For each of them, you can argue for the claim or its negation, etc. For is bad for your health, it's not bad for your health. So that's how I designed this way back when I ran into the same issue. And that is also mutual exclusion, but you enforce by the nature of the thing you're modeling that you disallow claims such as pizza is more affordable than burgers. That's simply not allowed, because then that the claim is not about a feature which you're trying to talk about in your so a mutual exclusive set for me is different options where you want to discuss a claim on each of these options as either true or false. That for me is mutual exclusion.
I would go for a ranking on the, I call this ranking and criterion. Like this is the price, for example, or health level, or this and that.
It could,
But
yeah, that could be one. It depends,
but
right?
the thing about the ranking has nothing to do, in my mind, with mutual exclusion. The fact that in the case, again, of climate change, what should we do against climate change? Here are possible actions. We can take as many of them as we want. Maybe bound by a total cost envelope and a minimal action threshold envelope, right? But there's no, it's inherent in the structure of the question. Now, something about in IBIS, something that was often done is if you have things that vary on, like, for example, there's option A, B, C, but B and C are similar. What you can do is take whatever they have in common, make that into one option, and then create a new question below that joint, and then explain, okay, they're different on this. So you can first A versus the BC abstraction, and then have another vote between B and C if we choose the BC abstraction. That was a way to avoid splitting the vote between B and C if they're very similar. And this is where we get into feature lattice. But here it's orthogonal criteria. It's not even a lattice, right? It's something else, and you can do ranked voting on one.
Yeah.
But
so
it has nothing to do with mutual exclusion.
Yeah, true. I see. Yeah, you can that feature lattice is still useful even if it doesn't have to be mutually exclusive. But it's a way to actually remove false dichotomies, trichotomies, or whatever. Where you just
where before you go, Felix, quickly, where I do disagree with you is whenever you say I don't want this to be expressed. It's like, no, we want it to be expressed and refactor this out. the people will say sushi is very expensive, and the question is, okay, what do you mean by that? Like, capture it, then encourage to get something more precise that fits into a better scheme.
So
wait a sec, Timothy. I just wanted to note, like, we're talking about two different things here. One is mutual exclusiveness of independent claims, like the table is blue and the table is brown, for example, like claims that are not compatible. And in this case, answers to a question. And these are completely
well, but see, that's what I was going to point out, is that your example is also an answer to a question. It's just the question hasn't been stated. The question is, what is the color of the table, right? But do we really have to make a matrix? It's not a voting situation in that case so much as some sort of logical debate, but still it's mutually exclusive. It's the same thing I was thinking with the COVID question of, the virus was intentionally released from a Chinese lab, right? This came up all over the place. No, it wasn't. It was introduced by the Americans to blame China or something, right? It was an attack on China. No, it wasn't. It was, you had in the end competing theories, and there was a mutually exclusive nature. There wasn't always mutual exclusion because actually the theories were pretty complex, right? So you actually had different mutually exclusive elements. So you had, was it released from a lab or was it not? Was it intentionally developed in the lab or was it not? Was it released by the Americans or the Chinese? Was it, so you have several mutually exclusive elements in this theory. You could break apart into these mutually exclusive claim sets and from there build the other arguments. But it happens automatically, whether or not you're like trying to make a decision on a policy project or dinner or something, or you're just making a claim. A lot of claims end up being mutually exclusive with other claims.
I agree totally with that. Some questions become meaningless unless other questions are decided. Like, was it released intentionally is meaningless unless we've determined it was developed in the lab, for example. If it's natural zoonotic, as we all think it is, I hope, then the question of intentionality becomes totally unasked.
Right, but you would still want to argue against, no, it wasn't released intentionally because it was zoonotic, right?
Yeah. But what you want to
yeah.
do is say this question only makes sense in the context of this other question. Was it zoonotic or human developed? Right? And what's if only in the human developed branch do you can you ask a question about intentionality?
Well, yeah, sort of. Because I could easily see somebody arguing against it was intentionally released by saying it occurred in nature, right? Somebody would still connect that and make the argument. So I'd have to think about how the structures would work there. I think you would just have one mutually exclusive claim set out there and another, and one was, one of the outcomes would be used to oppose something there. I don't know. I have to think about that.
But I think we're saying the same.
Case.
I think we're saying the same. It is a good case. I think we're saying the same thing. We have in this case a kind of two-level tree, right? Zoonotic versus human, and then if human, and so you can argue against the intentional release by saying, up on the tree, we're not even in that branch. We're not even in the human branch. So it's an argument against that, but it's we're going at a higher level in the possibility tree, so to speak.
Right.
So that the question becomes moot. But anyway, I think we basically agree. Mutual exclusion is a phenomenon that is distinct, orthogonal to the question of multiple criteria for deciding between options. And arguments, a lot of them will actually be disguised either pairwise or global criterion evaluation, but some of them are just isolate. But most of them are have an implicit criterion. And if you have an implicit criterion, you're better to do it with a ranking than with pairwise. But that's another story up to a point.
Yeah. Okay. So yeah, that. What is a different structure that somebody could propose and we discuss. But I have some ideas about that. Go ahead.
Yeah, I'm not sure. I think the model that I'm seeing here is too complex. Okay, because I think it's bound a lot of things together when it shouldn't have. For instance, you should have options, and some of them might be mutually exclusive. Some of them might not be mutually exclusive. For instance, we can go, as it was said before, go subgroup. Every subgroup can go to other dinners. We can go for the first restaurant and then to the second. And I think you should consider only options at the first time and how you evaluate each option. And then you can say, okay, I want to say those are mutually exclusive or those are not mutually exclusive. Okay, those are two levels. And if you combine too many things together, you will get a spaghetti code or spaghetti model. So I advise to make it more simple. To go step by step. If what I'm saying is clear.
Well, this is a conversation I've had with Felix, because I do tend to think of all these things at the same time. He's saying, oh, please have layers, but I do think all these elements have to be there. But if you can separate them in layers, yes, sure. It's easier to think about things in layers.
Yeah, and I'll show you another complexity that I'm saying. For instance, pizza is more affordable than burgers. If you say pizza is costing $5 and burgers cost $10, so you get this without making it complex, and then you'll find a pizza that costs $4. So she's more affordable, but you don't have. Think when you have millions of options. For any question, there are millions of options. Then you say, this is more than that, that is more than, you get such a complexity. Just give it a price for $99. That's all.
That's it depends again. In the case of price, you have a single linear scale. Wonderful. In the case of taste, what you have is usually pairwise comparisons and probably incomplete.
Yeah.
It depends on there's no linear scale for things, right? What you
I
can do is
say
ask
pizza
people, you
for
can
me,
ask
it's
every
10
person, I'm
and
not done, you can ask every
Yeah, sorry.
person to do a ranking. That's a classic way of doing, but I mean, asking people to do a ranking is a different interface. It's again, incremental formalization. Maybe that's not what you had at the start. Maybe what you had is pairwise or vague absolute, you know, burger is the best. And then what do you do with that? But yes, I agree. When you have that, you ideally, if the person's still around, come to them with an interface and please give me a ranking.
But again,
There
what's the
I'm with you.
Why
goal
not? Why
here?
ranking? Why not scoring? Okay, I prefer scoring.
It's a different thing. Total
Yeah.
order and partial order in
It's a different voting technique for
Yeah.
different users.
What is the goal
It's
for
used-
any of these? To decide on an outcome, or
Yeah, that's
Yeah,
for decision. That's all
option.
decision support system. And
Okay.
there, for
So
once,
that's
I agree with you,
not for
Stephen, that's about
canonicality,
scoring.
right? Okay.
I agree with you. That is a different domain.
Okay,
Yeah,
but then,
we're
then
not
the question
okay,
is,
but
in to what degree do we need mutual exclusion to obtain canonicality and centralization of this agreement? Both, I would argue, and that's the fact that one supporting one claim opposes the other claims, right? That's the thing that we're after, that relation.
True. And I think this is a bit beyond scoring, but yes, I think what Tim is introducing is if we have mutual exclusion, it enables us to infer certain propagated claims.
Yeah,
Absolutely.
or well, and then the question remains: can we? And apparently, we cannot always. We can suggest. So it sounds like almost the best we can do is, if there's a mutual exclusion set, suggest to the user that you also want to add this claim as opposing claims to the other claims in the set. But is there any way we can model or infer or decide in any way that is formalized when that should or shouldn't happen? That's my question.
And in a way, I agree with you. In a way, I don't. In a sense, I think this should be pluggable in the sense that a community decides this is how we will rank this. This is we adopt Robert's Rules of Order, we adopt whatever voting system, we adopt, unfortunately, first past the post in Canada or ranked ballot elsewhere, or this is a community agreement to use a certain way to resolve decisions when it's a decision issue. At our level, which is not necessarily a decision issue, or this is a separate domain, I think it's about pointing out when it's a bit strange when you're giving absolute support to mutually exclusive options, for example, or if you have counter arguments to all mutually exclusive options. It's okay, well, okay, you have reasons against. Now, is there a way to break that tie and point out some breaking needs to happen, or come up with a new option, which is also another way to break the tie. For me, it's about indicating to people, here is where the conflict is. And that way, what I did like about what you said about your notion of canonicality is, let's try to expose where the debate lies, 100%.
So a couple things I would like to bring up here at this point. One is, I haven't shown you the actual mapping part, which is something I'd like to show. But also what's been brought up here, because this is a generic structure, and I fully accept that there are false dichotomies and that people can point out something that you thought was a mutually exclusive set, they can propose a compromise or something, right? So I definitely agree there's an element of somehow evolving the mutually exclusive set. On the other hand, I don't think you have, even though you have false dichotomies, you sometimes have real dichotomies too. And you get this situation, you get this explosion of arguments whenever that happens. So I think we would need to consider what are the, what happens when somebody realizes that this is a false dichotomy, right? So for example, if somebody proposes that burgers are actually cheaper because they come up with a new one, that's an argument against the argument that pizza's cheap, right? So that's okay. In the case where it's no, we could go to Bob's Burgers and then Amici's Pizza. Somebody proposes that option. One solution to the problem is, again, you have an explosion of combinatorial explosion, because you can then just throw in a new claim, which is we should go first to Bob's Burgers and then to Amici's Pizza, right? It's just a new mutually exclusive claim. It's probably flattening out something more interesting and more complex. So, and another thing that's been brought up is we have to think through the evolution of mutually exclusive claim sets of, are they composable, like Marc-Antoine was saying. So these are all things that I would like to think through some more. So all that being said, let me just show you some ideas around mappings, or at least a concept of what a mapping might look like. Oh, the third thing I want to say is you talked about talk about why are we doing this and how does this relate to canonicality? These are essentially what you would say second layer structures. You no longer have to just talk about canonicality here. You're proposing the structure for some other so that. It could be that I want to control scoring in a better way. Because, for example, one of the problems you have in this structure in a base layer is it's never fully complete. If these three options are actually mutually exclusive, even only having these right here, I'm missing the arguments from this one to this one, right? You have somebody doesn't make the counter argument that should be applied in the other place. You have missing connections, is what I'm trying to say, when somebody is filling this out in the base layer. And if your scoring algorithm isn't intelligent enough to find those missing connections, it's probably giving a slanted score. And so by simplifying the model and placing these constraints or doing it automatically, that would be one of the so that's, is that scoring is more accurate according to what it's trying to model. So the mapping, the first step of mapping would be, in the case that you have a mutually exclusive claim set, you would automatically say that each claim is an argument opposing each of the others when you're mapping it to the base layer. Like if you were to create this in a higher level tool where you declare a mutually exclusive claim set and you create 3 claims and you save it to a base layer, what it would automatically do is create the 3 claims in the base layer and then create oppose arguments between all of them so that each one of them opposes the other. That's the first step of the mapping that I'm proposing here. The next situation is what happens when somebody creates a support claim, a support to one of the claims in the mutually exclusive claim group in the higher layer. You would automatically create the claim in the base layer. You would create the support to the claim it supports, and then you would create opposes to the other mutually exclusive claims.
So that was a question here. There was a question, right? That doesn't always seem to be the case.
When is it not always the case? It's only, in my understanding, it's not always the case under 2 situations that have been brought up. One situation is it's actually a comparison between 2 things, right? Which I hadn't thought through here. And I think the solution is when you create a comparison between 2 things, the structure would have to recognize that you're doing a comparison, right, between 2 things that are mutually exclusive. And in that case, it would have a different mapping, which would be if you're just comparing 2 things.
Which structure, the base layer, the second layer,
So you would have to know that a given argument is a comparison between 2 points argument versus an absolute argument. So you'd have to input that somehow. Say this one is an absolute, hence propagates. This one is a relative, hence doesn't propagate.
Now, even on the higher layer, this may have to be an incremental thing. Somebody just goes and said burgers are cheaper, right? And that would be mapped this way, right?
Which is as an absolute. And then
yeah, and then
say,
somebody,
no, actually,
yeah,
I meant only compared to pizza, and then replace it with the relative.
Exactly. So you'd still have this incremental improvement of the map. Yep. So all these cases would have to be considered, you know, in each layer how it maps.
For this to work, like the assumption is that support is clearly defined, because that's also something we didn't talk about yet. Like what's a good definition of support? That was always a bit fuzzy, I think.
Our definition is very clear in the model, I think. And I'm talking about the model. A support is a subclass of claim that has a premise that is a claim and a conclusion that is a claim. Right, if it's a support, it's supporting the claim, and if it's an opposed support, it's supporting the negation. But that's all at the model level, and that's very clear in this instance in terms of mapping. Because
and there's absolute support and weak support, but it's true, the semantics is a bit underdefined, but the intuitive notion is if the premise is, because I think they should still be plural since we're saying compound claims are not claims. If the premises are true, then we believe that the conclusion is more likely to be true, or absolutely likely to be absolutely true if it's an absolute support.
And then the negation is less likely to be true in this case. Yeah.
Or absolute negation in the case of an absolute negative support.
Yeah. Okay. We're at the hour now, by the way.
Yeah, I can go over, but if anybody can't,
I can go a bit over, but let's say 15 minutes.
I have to move.
I was wondering if Stephen, you want to take over the hour for tomorrow, because it seems to me like you have a strong idea of what we should do in some different aspects.
Well, the main ideas that I'm pushing for is simply to translate everything to a base layer, which focuses primarily on centralizing disagreements. And on top of that, then indeed focusing more on scoring, which would include structures like this. But I don't know to which degree we can have a session about that, other than we've already had so far.
Yeah, up to a point, I think the duty's on us to, like, or at least on me. I said the problem with that, the problem I have with that is that then the logic layer has to do all the work of the logicless layer and then some. So basically, I have to show how I would do the logic layer, but then the burden's also on you. If you see a way to do the logic layer as an add-on to the logicless layer that doesn't reproduce everything, maybe that burden's on you.
But reproduce what? Because the base layer is absent of logic. I recognize that there's only support and oppose. So any additional formalized logic is in the other layer and would simply point to atomic elements on the base layer.
My objection is I'm saying it's not a good layer boundary if the upper layer has to redo all the work of the lower layer. And I'm saying I don't see how to do it without redoing, but maybe you see a way of adding the
redo which work? I don't understand which work.
Let me see if I can translate. Let me see if I can translate here. What I'm showing here is a mapping from a higher layer to the base layer. That's pretty straightforward. I think we understand it. In this case, well, we can talk through the things you
push aside the main problem, whether or not a claim opposes all the other claims in the set. Like there's a magical solution out there you pointed to, but it's very unclear what that is.
Yeah, but
okay. Well,
like my assumption is it's simply
let me translate
decision. But
let me do the translation before we go off in this other question. I'm defining here a mapping, okay, and I'm saying if you do this work in the top layer and you use this structure, then it can store it in the base layer by mapping it into these base layer structures, right? Is that understood? And the question is, what happens if instead you do all the work in the base layer? Are you going to be able to see it in the second layer? Or like he's saying, is he going to have to redo all the work in terms of, oh, they've got all this stuff here and it should be this
I guess,
logic,
oh, okay, so the
I'm
question
gonna
is what,
restructure and-
okay, so the question is, how does base layer stuff show up in a second layer? Yeah, okay, my thing there is it wouldn't. The second layer only contains what is in the second layer. And if you want to pull in automatic stuff from the base layer, it's underformalized, so you don't do that.
And that's what I'm contesting. I'm saying the way I envision the base layer, the second layer, I would have to put in the second layer all the information that's in the first layer. So the second layer becomes, the first layer becomes redundant. If you think you can write the second layer as, here's the first layer, here's only the second layer as an isolate, and I can just have them, write the second layer so it doesn't contain all the information of the first layer, but just adds what's missing in the first layer, then I say you have a point about separated domain. But what I'm saying is I see no way to write the second layer without having to redo all the work of the first layer differently, and then the first layer becomes totally redundant. That's how I see it.
But
Sorry,
I think
have
then,
to go, so we'll see you on Friday. Okay.
Okay.
See you,
Okay.
Tom.
See you,
Bye-bye.
Tal.
see it all. So I
mean,
think
in terms of compound, for example, take compound, it's very easy.
wait. Let me pause it just 1 second, then we can talk about compound. But I think this is something that rather than discussing in the abstract, we should discuss on a case-by-case basis, which is why I'm proposing the mapping structure to do that. To say, okay, well, what is the burden on the second layer? What is the burden on the first layer? What happens when there's a change in one or the other? And is it compatible to just keep the layers separate? Or do we have to, in order to support it, bring it into the base layer? I think it should be a case-by-case discussion rather than a general.
And I agree. And that's why up to a point, it's for me to say, what do I expect the second layer to do and to come up with structures. And it's up to Stephen to show, oh, I can make those structures totally factored out on the base layer, which I don't
know if it's up
possible.
to Stephen necessarily. I think it's whoever's defining the mapping. If you understand the base layer, you should define how the mapping would be done and highlight problems where, look, this is loss of information.
The question is, Stephen claims that there's a base layer that can be isolated, that is meaningful on its own, and that can be factorized out of the second layer. I don't think that's possible. I think, or at least I don't think that's possible in a way that the second layer gets thinner in the process. And so that's, I have to define my second layer better. Here is what I want to express in the second layer. And I'll do it as a full layer because I don't believe the factorization is possible. And if Stephen believes the factorization is possible, I'm sorry, that's on him, right?
Yeah, but we need to talk specifics. That's why I want to compound. We can do that tomorrow, maybe.
We'll do some of it because I won't have the full second layer specified by tomorrow. I'll have
not the full one, but just do one bit at a time. Let's start with an easy one, such as compound, because that's the whole point. I'm saying compound is.
I don't think compound is easier.
But let's do it.
But compound is.
I wanted to. Yeah.
I don't know how much more I'll be able to do today. I'm having my vaccine in
like 5
hour.
minutes maybe. Nice. I'm desperate. I don't think I need more than 5 minutes here. The other points I wanted to make about that, going off of what you were just talking about, is in this structure, in this case, I have to think about all the problems that with what happens when it turns out not to be a
absolutely
dichotomy, if it's false, when they're not actually mutually exclusive, right? What happens? How does that evolve? I'll have to think through that. There's a couple other things I have to think through. But in this case, I think it does make the second layer be thinner and the base layer could be the storage layer of this. And you could see it just on the base layer. because in this case, and I think it's a rare case, you can have a two-way mapping. It means you can go back and forth between the two. And this is because you can intuit from an incomplete base layer version the full second layer version. There's something else I show here, which is what happens with supports or opposing a support. It's analogous. It still works. You just have to think through all these other cases. But in this case, there's a mapping. I saw you could do a mapping. If you have 3 claims and they're somehow opposing one another, they're being used to support and oppose each other. And essentially you have a cycle. And I haven't mathematically thought through all the possibilities. So, you know, there's a lot of graph theory that could be done here to decide what is a relevant cycle that could be considered mutually exclusive. But the intuition here is if you have several claims that are in a cycle of opposing one another, and it's a tight structure, it's not a big sparse graph here where there's a lot going on in between. So that's hand waving, I know, I'd have to think through it. But if you have a tight group of claims opposing one another, you could turn that into a mutually exclusive claim structure on the second layer. So you can read that in the base layer and say, okay, here we have this structure. And then if you have, I think if we had, here I have a sparse example where you have burgers are bad for your health, and it's opposing one and supporting another, but not the third. What I was going to say is you could intuit into it's actually supporting all the others and opposing one. But in this case, you can't really do that because of what Stephen pointed out, which is it might just be comparing 2 of them, right? So in that case, you'd have to leave it alone and let somebody fix that one, right? But if it's just one case where it's like, okay, this is all alone opposing that, you could automatically reverse that and say, well, it automatically supports all the others, right? In fact, you don't have to reverse it because that's the way it looks in the second layer, is it's only pointing at one. If it were pointing at all 3 and it matched the pattern of opposing only one or supporting only one, then you could get rid of all those others in the second layer and just show the one it supports or opposes. And the same thing works for the opposing support or opposing an opposer and so forth, right?
And
if you were to start playing, go ahead.
And as I said, in event sourcing, you would say it opposes all those that were introduced before because we have timestamps for each claim.
Well, but yeah, they would be on the second layer part of that set, right? So if anything new comes along that's part of the set, the second layer would fill it out and, you know.
Yeah, but what I'm saying is you would, if you make an absolute statement like burgers are bad for your health, you know, or burgers taste best, like, then you would assume that it goes against the other older options. But if a new option comes, maybe it wasn't considered at the time the best claim was made. So if you want to extend, you'd extend more weakly at best.
Okay, but see, but in this case, burgers are bad for your health. It is not saying burgers are the worst for your health out of everything.
Yeah, it is different. That's why I shifted to the other one. Yeah. But I'm also saying,
the other one, when you're comparing 2, a new one doesn't change. Yeah, when you're comparing only 2, a new one doesn't change.
Correct. But whenever you're saying it's bad for your health, you're kind of implicitly saying, as opposed to the other ones just stated, implicitly. And it's a weak, and it could not be the case, but there's a
but that's where the relevance arguments,
inference.
Right. Yeah, that's where you start to have relevance arguments, or you know.
Plausible inference.
I would have to flesh this all out more to see exactly what happens. Yeah.
One thing I'm doing, by the way, is a 2-axis logic. So basically saying, here's the strength of the support and strength of the opposed another axis, so that you can say, you know, here is unknown, we don't know, here is highly controversial, and here is, you know, opposed without without support, support without oppose, but you can have all these other regions, and you can say, there's a weak support, strong oppose, and so on. And each of them has a meaning. It's how strongly is this believed and how strongly is this disbelieved, and you get a kind of social logic.
Yeah, and I think all that is handled by an argument map, actually, in the way we defined it, in the support and the argument.
An argument map will basically what you do is you do the max of the arguments on the argument map, and to give you the support, and the max of the oppose to give you and then you just compute you plot the max against the max, and this gives you the social logic. The social logic value. So controversial, accepted, refused, or unknown.
All right, we're at 1:15. If people need to go,
yeah, it's a good
go.
time.
I was interested in following up with Stephen about your questions or confusions or objections about the structure.
It's not a confusion. I thought of these structures as well in 2018 when I first ran into the camel case versus underscore use case. And like I said, the main problem is who, when, what, how do you decide when you add a claim, whether or not it opposes all the other ones? And once you recognize that, so there's two choices. Either you fully formalize it and you require the user to fully formalize it, at which point you detract a bit of the value of the structure. Or at each addition of a claim, you ask the user whether or not it should be added as opposing, which kind of highlights exactly like you're doing here, that the base layer doesn't have this structure and the base layer only has support. I mean, this is the way you represent the mapping is the way that I also intended to do it. It's more like a feature that simplifies and automates some operations on a base layer. Like if you add one support, automatically you can add opposition to all the others.
I mean, I will say some other things too. I mean, first of all, we know that if we're talking about what is it, incremental formalization, when you add it, it's just floating out there. It's just a sentence. It's not connected to anything. I mean, unless you're adding it as an argument to something or whatever. There's some information you can intuit from the process they're doing and the tool they're using. But with much more formalization, I would say that my intuition is that a large percentage of claims that are mutually exclusive have the exact same claim structure in the canonical way that I think of it, and vary on a single parameter, right? They vary on a single definition, right? So, it's like, we should have dinner at restaurant. And so that restaurant is an entity in your claim, and the variation on those are the mutually exclusive claims. And so if you create a new claim and you specify all the entities and everything, so it's fully formalized in that sense, you can automatically intuit that there's probably a connection here of mutual exclusion, and your tools could check that or highlight it or ask you about it or something. And it's not necessarily mutually exclusive, and it depends on the situation, because we should have dinner at Amici's Pizza is obviously, there's a lot of ambiguity there, because who's we, who's, when's dinner, what date. There's a lot of things that you need to nail down for you to absolutely determine programmatically that it's mutually exclusive. But at least you would have enough to ask the person, that sort of thing, right?
Good time to stop.
I guess so. I guess we stopped. All right. Thanks, guys. This was fun again.
Yeah.
See you tomorrow.
Thank you. See you tomorrow.
Thanks.
See you tomorrow.
And good work. Thanks.
Thanks.